All right, hey everyone. Um, Happy snow day. Today we have to go ahead and finish up with section 8.5 using intercept form. So yesterday you guys were expected to watch the videos on the first half. Now we're gonna go through and finish up the second half. So let's go ahead, let's get started. First off, with this first example, we're supposed to use the zeros to graph this function. Okay, so right now, something that we need to start getting in the habit of is recognizing what form is this in. Right now, we're in standard form. Okay, so we're basically just going to start by taking this function in standard form and we're going to factor it. So here's my h of x. We've got x squared minus 2x minus 3. So we're just going to take this, we're going to factor it. Remember, x squared is going to turn into x times x. We've got negative 3 and negative 2. So that means that the first factor is going to be negative 3. And then the second factor is going to be positive 1. And then the beauty of graphing in standard form, you guys, is that as soon as you recognize these factors, you are able to basically, again, just take each of them and set them equal to 0 and solve. Okay, so here if I add 3 to both sides, one of my x-intercepts is going to turn into 3. And then if I subtract 1 from either side here, I've got my other x-intercept of negative 1. Okay, so now what I'm able to do is go ahead and plot each of these points. So 1, 2, 3, and then negative 1. The other nice thing about standard form, so basically, you guys, each of these forms has their own positives and negatives. But the benefit of standard form is that once you get the zeros, and then you can go ahead and you can just take and figure out, well, where is this where's this crossing the y-axis? And that's at negative 3, so I'm going to go down 3 here. Um, and now we're also able to figure out where that axis of symmetry is. So I really like this problem because it kind of does a little bit of spiral review of some of the other stuff we talked about with standard form. Remember to find our axis of symmetry that's opposite b over 2a. So let's just quickly figure that out. Our b value is negative 2, so opposite of negative 2 divided by 2 times our a value is 1. Okay, so that's going to turn positive, 2 over 2. So our axis of symmetry is going to be at 1. So I'm going to throw that axis of symmetry in there right here. And then I'm able to just really quickly figure out, okay, I've got my axis of symmetry. Let's just figure out the entire vertex. So for part of the vertex, we've got the x-coordinate. Let's just quickly figure out the y-coordinate then. So that's going to be 1 squared minus 2 times 1 minus 3. So 1 squared, that's just 1, minus 2 minus 3. So that's going to bring us to negative 4. So I'm at 1, negative 4. All right, now I'm able to just go ahead, connect all the points, and graph in this form. So the rest of this lesson, you guys, is a lot of just kind of reviewing and identifying which form we're in, how can I graph, how can I solve based off of the form that I'm in. I'm going to do example 7 with you guys. Then your job is going to be to do example 8 on your own. And then actually example 8 is pretty much identical to the previous example on the last slide. So that one should be fairly quick and fairly simple. All right, this time with number 7, what form are we in? Okay, well, remember standard form is ax squared plus bx plus c. Vertex form, you're able to pick out the vertex right from looking at it. That's a times x minus h squared plus k. This time, we are in intercept form because when we look at it, we're able to pick out both of the x-intercepts. So I've got an x-intercept at 1, and I've got another x-intercept at 4. So I'm going to start just by graphing those 2 points. There's 1, there's 4. Remember, for intercept form, in order to find the axis of symmetry, you're just taking your 2 values, your p value and your q value. So that's p, that's q. You're adding the 2 together and then dividing by 2. So that would be 5/2, or if you want to say 2.5, it really doesn't make a huge difference. So I'm going to go ahead, I'm going to plot that axis of symmetry really quick. 1, 2, 2.5. Okay, and then let's again just really quickly figure out where the rest of that vertex is at. So 2.5 is the first part. I'm going to take 2.5 or 5/2, plug it in. So 2.5 minus 1 times 2.5 minus 4. So that'll be, let's see, 1.5 times negative 1.5. So that should get me to about 2.25, and that should be negative. So I'm going to go ahead, I'm at 2.5, down 2.25. So there's my vertex. If you really wanted to make sure that you were absolutely 100% perfect with the shape of this graph, figure out where it's crossing this y-axis here. And the way you would do that is just go ahead and plug 0 in. So 0 minus 1 times 0 minus 4. So that'd be negative 1 times negative 4, which would get you to 4. So then 1, 2, 3, 4, that's up here. And then you can just go ahead and you can graph your parabola just like that. All right, so I'm actually going to stop this video. You guys go ahead and do the next example, and then we will, in the next video, get started on the next type of example, which is writing quadratics in standard form whose graph satisfies the given conditions. So first off, your task, go ahead, do problem number 8.